Hi, welcome back to TechGuru-RealTime channel. Stay tuned until the last. You can understand the concept followed by the real-time hands-on session. Today I am going to describe about how to work with completable future and how I am going to integrate Executor framework along with completable future. So let's dive in. So I'm using here Java is the language to solve these problems. How flexible Java come up with a lot of frameworks which solves our tasks easily. Okay. So what is a thread? How to create a thread or threads in Java and life cycle of the thread. How to create a thread pooling via executor framework. I have already covered in IT real world problems and solutions 4. Please find the details from the description. What is completable future? So completable future is something Java team has come up with mix of various concepts like a future task. Say if I'm performing thread level an operation, what are the possible things can happen? The task can be successfully completed, or if you want to cancel the task, yes, you can do the canceling, or while performing the task there could be exception thrown. Yes, it is possible. And say if it is successfully completed, say I wanted to get the results from the multi-threaded environment. All these things basically we wanted to evaluate whenever we are building any of the application. So that is where this completable feature is going to support when it is being working with the multi-threaded environment on a single application, which is the actual JVM process. Okay, asynchronously operations are being performed, okay, in parallel, not sequentially. It can perform span and then it starts performing, uh, and then it can aggregate the results and then give it for us. Okay, that is nothing but chain of stages. Completable future nothing but multiple stages of the results. Stages can be completed or cancelled or thrown exception. So so that is how this framework implemented. So it uses a future. This future is defining the following things: is the task completed, or the task cancelled, thrown any exception, or get the results. This set of things is going to govern from the future side. And completable feature uses the other set of APIs internally to solve our problem easily. So fork join pool, fork join task, and so forth. Not only this, I just highlight here a couple of things. Likewise, they use the overall threading concept to manage different stages when we are performing asynchronous operations. Now I need to perform based on the threads which I am defining. How I am going to use the defined threads at my side. So I'm going to use executor framework to define the set of threads at my side. I wanted to use along with the completable feature. How I'm going to do it. Let us try to understand the input. Say for example, I'm going to create a thread pool of 5 threads, and I wanted to perform task 1, task 2, task 3, and then make sure that my executor framework thread pooling has been properly closed. Otherwise, I may get wrong results. So this is how I'm going to define the parallel tasks, and let's try to print it on the console. So for testing this, we must need core Java. I'm using JDK 18, IntelliJ or Eclipse. This is not necessary in case if you want. This is used by Java developers. So audience could be Java developers who has experience. So these are the reference links. And now let's dive into the hands-on session. This is problem and solutions number 5. So I'm going to create a new object. Let's say completable future app, so that I can easily understand what is the point of this. Let me create a main driver. So my main driver is ready. Now I need to start performing according to that. I need to build thread pool executor that is using executor framework, and then followed by the completable future related tasks. How I'm going to do it? Let's see it. Completable future. This is having lot of methods. There are certain instance methods, there are certain static methods. Okay, so I need to do static importing. Let's see. Let me go ahead and define. So I'm going to define, say I wanted to do multiple tasks, I want to compose all these tasks in parallel. So there is a method called supply. Supply asynchronous. So this is a supplier based Java 8 fundamental. It has been derived. I have supply, I'm specifying. Now if you see, there are two ways where we can direct object supplier with executor framework, right? So first I'm going to create executors framework. Executors is a class dot new fixed thread pool. As I said, I'm going to define 5 threads. So now I can see that executor I say. Now what I want to do is, if you look at it, this is a functional interface which is being used. So what I'm going to do, I'm going to use, say, initially task 1. I am going to perform. So that is what it is talking about. Supplier and followed by executor. There are two types of static methods. I pass it executor. Now I need to define what is my task 1. So I'm going to create a method. Say simply I'm doing a return stating that task 1, for example. Now I got this task 1 result. Now what I supposed to do is, I supposed to do other parallel tasks based on task 1 results, for example, dot. Then there are variety of syntaxes you can see. There are many, so you can use. I'm going to use currently then compose. I am interested to do here the compose operation so that I can compose many tasks at my side. Whatever the results which I received, I say result 1. I'm going to do it. Now in the compose I want to perform, there are multiple tasks. Say, now I'm going to say task 2. So before performing, I want to combine all the tasks, right? So I had to run. So how I can do all of? There is a static method which is defined. Now I use the all of, and then here I can able to perform all the tasks. Okay. So here I can use run as a runnable task 2, my executor. I'm composing basically multiple tasks in parallel. Let me create task 2. Okay, let me create task 3. Let me create task close. Why do I need close? Because I'm supposed to properly close my resources. If I do not close the resources appropriately, then there will be a problem. So that's the reason I am going ahead and having the close method. So let me use as an executor. So that's inherit. Now you can see that. So because I'm running multiple tasks which I wanted to perform. So initially I am making a supplier. So this is going to make a call to this, getting the result, and then that result is being used, right? Say I'm going to use result 1. So I need to define, say, string result 1. Say here also I'm using result 1. For example, according to my use case, I'm going to define task 3 result 1. Okay, so this is being an object. So what I can do is I can typecast here as a string. The same case here as a string. So what I'm doing is I'm making a task 1 operation. This task 1 is operation is going to use some executor related thing, and then I'm performing task 2 based on the result, task 3 based on the results, for example, and I am also using executor framework. And finally I want to close all the threadful executor which I have created it. In case say that if you want to perform using executor, you can pass it as an argument here, but in this case demonstration purpose I am not using that. Say I say return, I'm saying that result 1 plus, I'm saying task -2 for just printing purpose. This is a runnable task. So if you look at it, we cannot return anything because runnable do not have that flexibility. So what we can do is we can do a console, or we can perform some operations here. Call some operation. Okay. Here as well, call some operation. I'm just using only for demo skeleton purpose. You can learn how to write the code. Okay. And then here I'm specifying the println statement like this. So in case if you want, you can pass the executor and perform your operations the same way with task 3. Here I say task 3, call some operations, whatever you wanted. Okay, I'm not going to talk about it. So now what I can do is, this is the very critical step wherein we're supposed to close it. If we do not close the executor, then there is a thread pool leak which causes non-consistent data. So that's the reason we must ensure that we are fulfilling this. So this is the method. So let us go ahead and use this executor service that has a service lifecycle methods. While I'm saying not executor dot is terminated until all the tasks are completed, then this will return true. Then we can come out of this loop. Otherwise, we don't need to do exiting. So that's the advantage of this thread pool executor. We are going to use it. Okay. So now you can see that I started completable feature, and this completable feature is being used and perform parallel tasks, task 1, task 2, task 3, and then make sure these two are sufficiently executed to close the tasks. Now let us go ahead and execute and see whether this code works or not. So this is how I created executor framework, and using the executor framework I'm able to build parallel tasks running asynchronously and do whatever tasks as per my application demands. So very simple, elegant code where you can try it. Let me run it. I can see that task 1, task 2, task 1, task 3. If you want to see here as well the console message whether it's being called or not, of course you can do that. You can say task 1 rerun. See, let's go ahead and run and see all the tasks being called or not. We can see that. We can see that task 1 being called, task 3 being called this time, then task 2 being called, and my thread pool executor is not yet properly shut down. That means still being referenced. What is the root cause? This is shutdown. We are executing at the final call. That's the reason this is not being shutting down. These tasks are not being. So what we supposed to do? We supposed to make call here executor shutdown executor is terminated, because that is being called parallelly over there, which is not good. Now kill this and go ahead and run this. See, now you can see that now properly my executor service shut down and terminated. If you do not close it outside, your threads are still alive and you may get into wrong results. So this is very important to understand. This is not being called because these three tasks being parallelly called, and one of them is being using and it is not killed the life cycle. So be cautious writing all these precise code when we are dealing with the applications. Thank you. That's the end of the demo. Please like it, share it, comment it, and subscribe it. I come up with new videos. Stay tuned. Until then, thanks. Bye.